you are overseeing the development of a new educational platform and are in the process of scheduling key tasks. You have a two critical tasks ahead and 3-point estimates are as follow. Okay. Task A, design of a user interface. Optimistic time 20 days, most likely time 35 days, pessimistic time 50 days. Task B, development of content management system. Optimistic time 40 days, most likely 70 days, pessimistic time 130 days. Using the PERT calculation, determine which task is more predictable, that is, has a lower uncertainty in the duration. Yeah. So here you have an information available about two tasks and you have a 3-point estimates available. Now we are saying that we are looking at the number optimistic, most likely and pessimistic, which task looks having less variance, more predictable. So you can say when these three numbers are very close to each other, when the gap between optimistic and pessimistic is less, we can say that we are more predictable about that particular estimate. And when the gap between optimistic and pessimistic is high, we know that our estimates are more expected to be uncertain. There will be more variability into it. Now, in order to get it little calculated way working, in our PERT calculation, we also have a formula for standard deviation. And that standard deviation is calculated by pessimistic minus optimistic divided by 6. So it's like taking the outer range of these two estimates, and since we use 6 as a number, so divide by 6 and it comes to a standard deviation. So in a simple word, we just need to calculate the standard deviation for these two thing, or we can just calculate the range also, because divide by 6 is common in both the places, and need to see where the standard deviations are high, the uncertainties are high. When the standard deviation is low, uncertainties are low. So that's the only calculation we have to do. So we can do that. First we can calculate the standard deviation. So let's say task A, the deviation could be pessimistic minus optimistic divided by 6. So 50 minus 20 divided by 6, which is 30 divided by 6, which is 5 days. So we can say the standard deviation for task A is 5. Then we can say the standard deviation for task 2, pessimistic minus optimistic divided by 6, 130 minus 40 divided by 6, 90 divided by 6 comes to 15 days. So we know that, okay, standard deviation of task B is more. So B is less predictable, A is more predictable. That's the simply we know the answer. So let's look at the option now. Task A is more predictable because it has a lower standard deviation. Yes, that's the fact. Task B is more predictable because it has a lower standard deviation. No, the task B has a more standard deviation. We just calculated it. 130 minus 40, 90 divided by 6 is more. Both tasks are equally predictable as they have the same standard deviation. No, it's simple. Predictability cannot be determined from the standard deviation alone. It can be, it can be, because we are using here that standard deviation as a tool to predict the certainty in your estimation. So option A goes good with this particular question. Pure calculation question which you may face in your PMP exam. Simple calculations provided you know that you just need to check the range. So overall, we are mapping it to task 6, plan and manage a schedule. Loosely, it also couples with risk management, assess and manage risk, because here you are doing some amount of quantitative risk analysis, looking at the deviation between the optimistic and pessimistic numbers. So overall, the topics covered: 3-point estimates, PERT technique, as well as quantitative risk analysis.